Welcome, welcome to Unit 5 Polynomials for 5b. 5b, we're going to be factoring polynomial expressions by grouping. Now, we've done some of this in the past. I just want to quickly go over a couple examples so hopefully it can refresh your memory. The steps are here. Factor out the GCF if you can. Always do that. Always factor GCF right away. Next is to group the first two terms and the last two terms together. Factoring, step 3, factor out the GCF from both groups. Step 4, we're going to regroup the factors. And step 5, check those factors again, those regrouping of the factors, see if you can factor them further. So let's get started. Example 1. So factor out a GCF, greatest common factor, yes there is one actually. The greatest common factor is 3. So let's factor that out. So we have 3 and p to the third minus p squared minus 5p plus 5. Okay. Now what I'm going to do is just going to concentrate on what's inside of the parentheses. So what's inside of the parentheses, I'm going to group the first two terms and the last two terms. So the first two terms and the last two terms inside the parentheses. So I'm going to take the greatest common factor of the first two terms, which is p squared. I'm going to factor that out. So the 3 is already on the outside, and then you have the one set of parentheses, and I'm going to put the p squared inside of that parentheses, and then there's another set of parentheses. So it's like you're dividing each term by p squared. So p to the third divided by p squared is p squared divided by p squared, the greatest common factor. There's 1, subtraction in the middle. Next, I have the greatest common factor between negative 5p and 5. If this first term is negative, always take a negative out for greatest common factor. So the greatest common factor here is negative 5. So I'm going to put a negative 5 on the outside here. Dividing the first term by negative 5, I get p. Dividing 5 by negative 5, I get negative 1. So inside of the parentheses here, the farthest inside, the p minus 1 and p minus 1, those have to be exactly the same. If they're not, then you did something wrong, or it's not factorable. So let's carry this over. And we have 3 on the outside, and at this point we're going to regroup the factors. So I have 3, and then p minus 1, I have that in both factors, so p minus 1, and the other factor is on the outside, p squared minus 5. And now I check to see if I can factor either factor further. P minus 1 I cannot factor further. P squared minus 5. 5 is not a perfect square, so I cannot factor that any further. Therefore, this is my final answer for factoring. Moving on, we have factor this 4-term polynomial. So, greatest common factor, there is not one. Group the first two terms. Group the last two terms. Greatest common factor of the first two terms is x squared. Factor that out. X minus 2. Greatest common factor of my next two terms is negative 4. And that'll be x minus 2 left over. Let's regroup it. We have x minus 2 times x squared minus 4. And this is where we're at the last step. Check to see if we can factor either term or either factor further. X minus 2 I cannot, but x squared minus 4, this is a perfect square binomial. It has a subtraction in the middle, so I can factor this part further. That should be an easy factor of x minus 2 and x plus 2. And then we have an x minus 2 in the beginning. And since I have two x minus 2's, let's even make this a little more simple. You'll have x minus 2 squared, because you have two of them, multiply together, so that's the same thing as squared, plus 2. And there's my final answer for factoring. Alright, next we're going to do factoring polynomials using the sum and difference of cubes formula. Fun, fun. So here we have two formulas. You're going to have to memorize these formulas. So let's get started with them. The sum of cubes, it's going to be in the form, the first term is going to be, you're going to be able to cube root it. And the second term, you're going to be able to cube root it, and because it's called sum, you see there's a plus in the middle. So the formula is a plus b times a squared minus a times b plus b squared. So with the addition, you have a plus minus plus. With the difference of cubes, you still have the first term you have to be cube rooted. The second term has to be cube rooted, but you have a subtraction here. And so we have a minus b at this time instead of a plus b. And you have a squared plus b ab plus b squared. And you notice signs, the first two signs are switched. There's an acronym to help you memorize the formula. This is called SOAP. The S stands for the same sign. So if you notice up here, the first sign, so the sign is a plus. This first sign over here is a plus. That's some pretty terrible pluses. If you notice on difference of cubes, subtraction and subtraction for the first sign, they're the same. Second one, O stands for, I bet you can figure it out, opposite. So if it's a addition formula, or if it's a sum of cubes, it's add. So the second sign is subtract, it's the opposite. If it's a subtraction, then it's a plus. And the last two letters stand for always positive. So the last sign is always positive. Maybe on both of them. So, main thing here, if you look at the actual formulas, they're really the exact same. You have a, b, a squared, a times b, b squared. You just have to memorize the signs, and that you can use with SOAP. So a, b, a squared, a times b, b squared. Alright, let's get working on some problems here. So I immediately noticed that on x cubed minus 27, that it's a subtraction, so we're going to do a difference of cubes formula. So we have, so what the first term, so first you see if there's a greatest common factor, always. In this term here, there's no greatest common factor. So what you do to find your a is you cube root the first term. So your first term is x. And that is in the formula, that would represent your a. The second term, you cube root it, and you get 3. This in the formula would represent your b. So we have a times b, or a subtract b. Then you have a squared, x squared is, or x squared is x squared. And then it's opposite sign, since this is a subtraction, this has got to be a plus. And then it's a times b, so that's x times 3. And then it's always positive. And then you take the b and square it. So that's 9. And this is my using the difference of cubes formula. Moving on. Next one, we have sum of cubes. So here you're going to do the exact same thing. Greatest common factor, there isn't one. Cube root the first term, you get x. Cube root the second term, you get 4. And so your a is x, your b is 4. First sign is the same, so it's SOAP, same, op, and then it's a squared, and it's opposite sign, a times b, and then it's always positive, b squared, and that is your final answer. Now you're thinking, well, this is probably pretty easy. Let's get to something maybe a little harder, maybe not, up to you. Might not be that much harder, but here we have 54x to the third minus 250y to the third. So is there a greatest common factor? Yeah, there's 2. So let's take 2 out. So you have 2 times 27 x to the third minus 125 y to the third. So here, so for right now, I'm going to disregard the 2. I'm only concentrating on the 27x to the third and the 125 y to the third. Are both of these, can you cube root both of them? And the answer is yes. You can cube root 27x to the third, and that is 3x. Can you cube root 125 y to the third? And that is 5y. So my a is 3x, and my b is 5y. So let's rewrite this. So we have a, and then it's a subtraction problem, so it's the same, minus b, and then it's a squared. Now 3x squared, if you're looking at 3x squared, this is the same thing as 3x times 3x, which will end up being 9x squared. So then it's the opposite sign. So now you take both a and b and multiply them together, so 15xy. And then it's always positive, and the b squared. So 5y squared is 5y times 5y, which is 25y squared. And this is it. Oh no, I forgot the 2. Do not forget your greatest common factor. So let's put that 2 out front here. And that'll be it. Thank you for listening. Come to class with questions.